Hi everyone and welcome back to chemistry, and this is Mrs. Hutchinson, and today we're going to continue talking about matter and change, more specifically talking about how to distinguish matter given examples. So as we get a little better, as we get a little farther into chemistry, these will kind of become intuitive, but until we learn a little bit more about chemistry and how it works, these are kind of the rules that'll help guide you in determining what's an element, what's a compound, what's a heterogeneous mixture, what's a homogeneous mixture. So, given these examples, the first one's pretty simple, pretty self-explanatory. If you can find it on the periodic table, it's an element. What do I mean by that is, say you're talking about copper. Copper's found on the periodic table. It's going to be an element. If we're talking about gold, it's found on the periodic table. It's an element. So if it's found in the periodic table, we're talking about an element. If it only has one and only one capital letter in the symbols, it's going to be an element. If we take a look at the periodic table itself, all of the chemical symbols contain one and only one capital letter. So looking at all of these examples here, we've got barium, hydrogen, neon, gold, of course, is everybody's favorite, uranium. And then etc. is not on the periodic table, but I'm still working on getting that one named. But if it has one and only one capital letter, you'll notice with each one of these symbols, they only have one capital letter. It's going to be an element. Taking a look at if it has more than one capital letter, that means that it's made up of more than one element. So if it's made up of more than one element, it's going to be a compound. So, taking a look at these examples here, we've got NaCl, which is table salt. It's got two capital letters. It means it's made up of two different elements, sodium and chlorine. If we take a look at baking soda, or sodium hydrogen carbonate, or sodium bicarbonate, it's got four capital letters. It means that it's made up of four different elements, which means it is, in fact, a compound. If we take a look at the next one, if it has a complicated two-word name, meaning it sounds like it's a compound, well, then it is a compound. The only exceptions are ones that we use on an everyday basis, ones that, rather than using their chemical compound names, we just use their abbreviations that we have that make life a little bit easier, such as sugar, salt, water, alcohol, and ammonia. Those are all compounds, but it's not a complicated two-word name because we see them every day in the store, kind of a thing. So this is what I'm talking about in terms of our complicated two-word name. Barium hydroxide. It sounds like a compound, so yeah, it is a compound. This is where you kind of have to use common sense. I know Voltaire was kind of right, common sense is not so common, but I think you guys are well beyond that. So use your common sense to kind of say, okay, this sounds like a chemical. So it probably is a compound of some kind. Probably some kind of chemical compound, if you will. Barium hydroxide is a compound. Hydrogen peroxide sounds like a compound. Yes, it is a compound. If you think it can be chemically combined, in other words, you can't imagine any physical way of separating it, it's a compound. In other words, if you can't separate it using a magnet or filtering it or boiling it, the only way that you can imagine to separate it is by exploding it, then it's a compound. Otherwise, if you can use some kind of physical means to separate it, it's a mixture. Again, this is where you have to use your kind of intuition and common sense. Homogeneous mixtures, they won't settle, and they're even and uniform throughout the entire container with which the substance is in. So our examples would be salt water solution. So remember NaCl, you've got that little aqueous. So solutions mean aqueous dissolved in water. You've got your sugar water solution. Of course, that could be any sugar water solution. It could be sugar, it could be the dextrose, it could be glucose, it could be sucrose, any of fructose, any of those oses could be dissolved in water. So homogeneous mixtures are uniform throughout. If something is produced that has completely different properties, then it's a chemical compound. In other words, remember our copper sulfate? We had copper-colored copper, we had yellow-colored sulfur, and colorless oxygen to yield that bright blue crystal. That difference in color was indicative of the fact that we had created a new compound. So that has completely different properties, therefore we created a compound through chemical means. If it can't be broken down at all, in any way, shape, or form, you can't imagine that it's going to be broken down. And I'm not talking about crushing a crystal. I'm saying at the atomic level. If it can't be broken down, if you've got lead and you can't imagine separating lead from lead, well, you're right, because lead atoms cannot be broken down at all, in any way, shape, or form, for our purposes right now. Then it's going to be an element. If it can only be separated chemically, meaning the only way that you can get it back into its elemental form, so in other words, if we have water and we wanted to create hydrogen gas and oxygen gas, the only way that we can do that is through a chemical reaction. You can't just simply take every water molecule and separate the hydrogen from the oxygen and just pick them apart like you would like grapes off of a vine. You can't really do that. You have to separate them, and you do that using some kind of chemical means. If we take a look at the next thing, if it can be separated physically, in other words, separated through boiling or distillation or using a magnet or filtering, of course filtering only applies to heterogeneous mixtures, then it's a mixture. In other words, if you physically put it together, you can physically separate it. So what I'm talking about is if you've got a beaker of sand and you've got a beaker of water, we add them together and you would get sand here and water up there. Well, they're physically combined, so we can physically separate them. Then you're dealing with a mixture. Here is where we get kind of the new thing. This is what I was talking about earlier. So aqueous. What is aqueous? Well, this little AQ here is very important. So AQ means aqueous. It means dissolved in water. So if you think about it, anytime salt is dissolved in water or sugar is dissolved in water, then you are dealing with a substance that is uniform throughout. So let me really discuss what number 11 is actually saying. So if it's got an S or an L or even a G after it, you're looking at an element or a compound. Now, what do these actually mean? So S is talking about, well, we're talking about something in the solid phase. L is talking about something in the liquid phase. And G is, of course, talking about something in the gaseous phase. So if you see something like that, for example, here we have NaClS, that's talking about solid table salt. So that's going to be a compound. So this is a compound. It's a compound because it's got two capital letters. If we take a look at this next one here, we have NaCl aqueous. That is telling us that we now have salt dissolved in water. In other words, we've got salt water here. That little AQ tells us that this particular compound is now dissolved in water. In other words, we've created a solution. My abbreviation for solution is that, just so you know. Since we've created a solution, it's a homogeneous mixture. So this is what I was talking about on our prior slides. So if you have any one of these S, L, or G's following our substance, it's going to be either a compound or an element, depending upon what substance we're looking at. If we have a little AQ after it, that's telling us it is now dissolved in water. Therefore, it will always be a homogeneous mixture. Whoa. So now, if we take a look at this, using our periodic table and reference table S, so reference table S is after our periodic table. The reason why you want to use reference table S is because it tells you not only the atomic symbol of that particular element, but it also gives you the name. So if you're not too familiar with the symbols yet, because we just got started, you can look up the symbols and the names on reference table S. But you want to classify the matter below as either an element, a compound, heterogeneous mixture, or homogeneous mixture, and just simply state how you arrived at your answer. It doesn't have to be a complete sentence. It can be a bullet. It can be a word or two. Just tell me how you got there. So, lithium. If you're using reference table S, you would find that lithium has an atomic symbol of Li. It's found right on the periodic table. So lithium is an element because it was found on the periodic table. Boom. Done. Next one, tomato sauce. Tomato sauce, tomato sauce. What do we know about tomato sauce? First of all, people tell me it's good with toasted cheese or grilled cheese, however you want to call it, but still not a fan. It's kind of gross. But anyway, if you take a look at tomato sauce and you let it kind of sit for a while, you notice that you get layers. So here's your little bowl. Let's say beaker because I can't draw a bowl. We let it kind of sit. We get like stuff settles to the bottom. You get this liquid on top and you get the solid on the bottom. I'm telling you, do it next time and you'll see. This is partially why I don't eat it. It's kind of gross. So since we have this formation of layers, it's a heterogeneous mixture. So many people would say, okay, but it looks uniform throughout. Well, it's cloudy, so isn't often cloudy one of those things that tells us if we're dealing with a heterogeneous mixture? It might look like it's uniform throughout, but if you were to take a spoonful of tomato soup from one side and a spoonful from the bottom, you would find that chemically speaking, they're not identical. Therefore, it's not uniform throughout. So go ahead and work on the rest of this particular worksheet, and I will see you on our next video.